Okay, so this is Module 4. It is Section 6 in the IPCJ Standard PDF. There's also a PDF for Module 2 and 4 that is in Canvas. If you would like to follow along with that, it's like the last 3 or 4 pages of that PDF. If you're looking at the entire book PDF, then it is Section 6. And also section 5.6 when we're talking about jumper wires. Okay, so for section 6.1, general through-hole termination requirements, axial leaded components, when mounted horizontal to the board surface, should be approximately centered between the mounting holes. That's should. The entire length of the component body should be in contact with the board surface. Again, that's a should. The maximum space between the component body and the board shall not exceed 0.7 millimeters, which is also 0.03 inches. It's a very small amount. However, since that is a requirement, but it is N1, N2, P3. So even if it doesn't meet that requirement, it is merely a process indicator and only for class 3. That is not a requirement for class 1 and 2. Components that are required to be mounted off the board shall be elevated at least 1.5 millimeters, which is 0.06 inches. Again, very small amount. That is a requirement for all 3 classes, and if that is not met, that is a defect for all 3 classes. But again, that's only if it's required to be elevated. If it's in the engineering that is required to be elevated, it needs to be at least 1.5 millimeters or higher. Continuing on with 6.1, components mounted in unsupported holes and required to be elevated shall be provided with lead forms at the board surface or other mechanical support. That is a defect for all 3 classes if not. For axial leaded components, at least one component lead shall have stress relief if the component is not clip or adhesive mounted or otherwise constrained. That's that picture right there. And this one right here on the upper right hand side. Again, if that condition is not met, that is a defect for all 3 classes. All axial leads shall have stress relief when the component is clipped or adhesive mounted or otherwise constrained. So if it is adhesive or glued down like this with the staked component right here, those are required to have all leads with stress relief. So this one right here on the bottom right would be a defect because stress relief is only on one lead. It should look like this one over here on the bottom left. Axial leaded components mounted vertically. So instead of being like long ways on the board, it needs, if it's going up, if it's tall. Axial leaded components mounted vertically in unsupported holes shall be mounted with lead forms or other mechanical support. Again, as if with the horizontal mounting. Vertical mounting, if they do not have lead forms, if they don't have that little bend right here, that would be a defect for all 3 classes. Axial leaded components mounted vertically in supported holes shall have component height in accordance with design. Again, defect for all 3 classes if not. Component clearance C from the land to the body, so this little measurement right here, or from to the body or well to bead, shall meet the requirements of table 6.1, which is right here, which is below. Let me see, can I get my pen going here? I don't know if I can. Oh, you know what? Yes, I can. Hold on, draw. I'm going to use red. So this is table 6.1. This is table 6.1. And so your C minimum for class 3 would be 0.8 and the maximum. So the clearance between the board and the body of the component is between 0.8 and 1.5. For class 3, you'll see that it's 0.1 and 6 millimeters. So this is for class 1. So this is a much wider range. Class 3 is much tighter. Clearance of radial leaded components that are mounted freestanding. So if they're supported by leads only with no spacer, they shall be between 0.3 millimeters and 2 millimeters. That's the clearance there. That is a process indicator for class 2 and 3. If not, it's acceptable for class 1. If not, the spacing between the component and the printed board shall not violate minimum electrical clearance. Again, if it violates minimum electrical clearance, it is a defect for all 3 classes. When spacers are used with radial leaded components, like what's shown here in this second picture, this is actually how we will be installing these on our boards. With these spacers, the mounting shall meet the requirements of Table 6.2. This is Table 6.2, and if they do not, it would be a defect for all 3 classes. So for this one, unsupported holes with spacer not in full contact would be a defect for all 3 class. If the spacer is inverted, it's a defect for class 2 and 3. It is no requirement for class 1. Really, as long as you can read this table, you should be able to answer any question about this slide, which you may see on the test. So lead forming. Part and component leads should be preformed to the final configuration, excluding the final clinch or retention bend before assembly or installation. The lead forming process shall not damage lead seals, welds, or connections internal to components. Again, don't damage your stuff. If you break it, it's broken. It's a defect. Leads shall, now this, I want to make very clear, this right here is A1P2D3. Okay, leads shall extend at least 1 lead diameter or thickness, but not less than 0.8 millimeters from the body or from the weld before the start of the bend radius. You will see something like this on the test. This one throws people off every time. Remember, it is only a defect for class 3, is A1P2D3. The illustration in your PDF, what figure is this? Figure 6.2 shows lead bends. It illustrates this point very well. And this is talking about the lead bend radius. This is a really good picture of what bend radius is. You imagine a circle here, and how many leads can you put into that circle? That's your diameter, your bend diameter, and half of that is your bend radius. So if your lead diameter is less than 0.8 millimeters, your medium bend radius, minimum bend radius is 1 diameter thickness. 0.8 to 1.2 is 1.5 diameters, and greater than 1.2 is 2 diameters or thickness, lead thickness. 6.1.2 termination requirements. Component leads and supported holes may be terminated using a straight through, partially clinched, or clinch configuration, as shown in these pictures. The clinch should be sufficient to provide mechanical restraint during the soldering process. Why we do this is because since we solder on the bottom, when we install these components, we want to clinch, we want to bend this so it basically stays in place. Because when you flip the board over, it's going to fall out if you don't. If you have it just with the straight through here, it's going to fall out. So you don't want to fall out. I'm trying to draw on here and it's not letting me. Ugh. Go. So the orientation of the clinch relative to the conductor is optional. Oh, sorry. The orientation of the clinch, so whether you have it that way, going right or left, sideways, whatever, that is optional as long as you have the clinch angle correct. Dip leads. If you are going to be clinching your dual inline package leads, should have at least 2 diagonally opposing leads partially bent outward. Now that is a should. That is a should. So when we are soldering our dips, if you don't have those bent, that's totally fine if you don't, because they're kind of small and it's kind of hard to bend them sometimes. You don't need to, because that is a should, not a shall. It's not a requirement. Lead terminations and unsupported holes shall be clinched to a minimum of 45 degrees. This is only a requirement for class 3. That is N1 and 2D3. Actually, and the one below it is 2. If the lead or wire is clinched, the lead shall be wetted in the clinched area. Again, N1 and 2D3. The outline of the lead should be discernible in the solder connection. Again, should. Tempered leads shall not be terminated with a full clinch condition. I believe we spoke about tempered leads before. You don't want to cut, bend, basically mess with your tempered leads at all, because they will break. Tempered leads shall not be terminated with a full clinch configuration, because once you bend it, it may break. So that would be a defect for all 3 classes. Lead protrusion, so how much the lead is sticking out of the board on the solder source side. Lead protrusion shall not violate minimum electrical clearance. Again, that would be defect for all 3 classes. And it shall be in accordance with table 6.4 or 6.5, depending on if you're using supported holes or not. Let me see what I'm going to show you real quick. This right here, where it's gold plated through, has the foil through on these. These are supported holes. Unsupported holes will not have that. I'm trying to see if there's a picture of an unsupported hole in one of these slides. I don't think so. Not yet. I think there's one up somewhere, but it's not in here. These are all supported holes. Yep, all supported holes. Connector leads, relay leads, tempered leads, and leads greater than 1.3 millimeters in diameter, so thicker leads, are exempt from the maximum length requirement as long as they do not violate minimum electrical clearance. And I want you to remember this, because you will probably see this on a test. So we're going to highlight this. Connector leads, relay leads, tempered leads, and leads that are greater than 1.3 millimeter diameter are exempt from the maximum length requirement. So for the protrusions, leaves, and supported holes, this is saying the max length for class 3 is 1.5 millimeter. But if it's a tempered lead, that doesn't apply, as long as it doesn't violate minimum electrical clearance. Okay, lead trimming. Leads may be trimmed after soldering if the cutters do not damage the component or solder connection due to physical shock. Tempered leads shall not be trimmed, and that is a defect only for class 2 and 3. Change back to my marker. So N1 and D2, D3. If your tempered lead is trimmed, unless specified on the engineering documentation. Leads may be trimmed after the soldering as long as the cutters do not cause damage. So if your lead goes up here, you can cut it like right there, as long as you don't damage your solder. If cutting leads after soldering, the solder terminations, so if you're cutting the leads after soldering, the solder terminations shall be either reflowed or visually inspected at 10x to ensure that the original solder connection has not been damaged, fractured, or deformed. It cut like this one. Lead trimming after soldering that cuts into solder fillets shall be reflowed. That is a defect for class 3 if it is not reflowed. This one is N1, D2, D3. This requirement does not apply to components that have breakaway tie bars. That is a portion of the lead that is intended to be removed after soldering. So that doesn't apply here. 6.1.4 interfacial connections. Plated through holes without leads used for interfacial connections need not be filled with solder. These little vias right here, you can leave those alone. If they're not required for connection, you don't need to worry about them. Okay, so we are going to go through 6.1 real quick with review. A lead that has been trimmed after soldering and cuts into the solder fillet, but is subsequently only inspected at 10 magnification. So it's been cut, the solder fillet's been cut, but it's been magnified, it's been inspected under magnification. Yep, it's been cut. what is that considered? Well, I just went over that. That is in 6.1.3, second paragraph. That is a defect for class 3. It is not a requirement. There is no requirement for it for class 1 and 2. A tempered lead exceeds the maximum lead protrusion requirements but does not violate minimum electrical clearance. Tempered lead, you can't be cutting it does not violate minimum electrical clearance. That's going to be acceptable. There you go. That's in 6.1.2. A lead that extends 0.7 millimeters from the body before the start of the bend radius. So this is like one of those really tricky questions. So leads shall extend at least one lead diameter thickness, but not less than 0.8 millimeters. And if it does not, it is A1, P2, D3. So A1, P2, D3. That is in section 6.1.1 under lead forming. Okay, so we are at section 6.2 now. Supported holes. 6.2.1 solder application. Solder shall only be applied to one side of the plated through hole except for intrusive soldering. This is N1, D2, D3. So we do not want to apply solder to both sides of the board. Heat may be applied to both sides of the plated through hole. That's totally fine. Just solder shall not be. Heat on both sides does help that solder flow. We don't do that in our class. It's not really necessary. 6.2.2 through hole component lead soldering. When soldering component leads into plated through hole connections, the goal of the cut process is to accomplish 100% fill of the plated through hole with solder and good wetting to the lands lead. I'm going to write this down here. This is in your book. Lands, leads, and barrel, top and bottom. So this is where you want to have good wetting on the barrel, top and bottom, lands and leads. Okay. The solder connection shall meet the requirements of table 6.6, which is this, regardless of the soldering process, whether you're using hand soldering, wave soldering, or intrusive soldering. A less than 100% solder fill may not be acceptable in some applications for like thermal shock or electrical performance. I do want to pay attention to this one about the percentage of land area covered with wetted solder on solder destination side. So where your solder winds up. This is required to be 0. Well, that's the minimum, because since you only have a 75% needed fill, say if you have this at 90%, say if you have these filled at 90%, that would be acceptable. But that means that you may not have the land area covered because the solder didn't go all the way through. So that is why this is at 0%. Circumferential wetting of lead and barrel solder destination side, you have to be able to see that the lead and the barrel, so inside the hole, is wetted and that the lead is wetted to it, but it doesn't necessarily need to be all the way up to the surface. Because if it's only 75% filled, that's still acceptable, but that means that it's not all the way up to the top, so it's not going to necessarily reach or go above the destination side. So that's why that is at 0%. Uh, 6.2.2. Still on 6.2.2. We are still on table 6.6, I believe. Yes. So this is table. Yeah. So this is going into a little bit more about requirement A. So when it talks about 75% fill, so what this one right here is showing us, this is a 50% fill, which would be okay for these two for class 2. There is no requirement for class 1, so either one of these would be fine for class 1. So the vertical solder fill for components with 14 leads or more, or vertical solder fill for each lead that is connected to an internal thermal plane on components with less than 14 leads, then it would be 50% for class 2. If you're doing a class 2 and is a vertical solder fill for components with less than 14 leads not connected to an internal thermal plane, then it would need to be 75%. This tends to confuse people, so you may see something like this on the test. If you do, you can ask for help. For class 3, however, it's 75% across the board, no matter how many pins it's got, no matter if there's an internal plane, whatever. Like this right here, this is supposed to be the internal thermal plane. Through the board, that's why this one's 50%. This is B, circumferential wetting of lead and barrel, solder destination side. Now this is on the land as well, but it's easier to show. But like right here on the right, it's more on the inside. But right here you can see it's not that great. There's actually some the right hand image does not exhibit wetting to the lead. So, oh, by the way, I didn't know if you knew this, but if you look at the notes when you went through here, sometimes what I say is in these little notes right here. So this doesn't show wetting. So that would be a defect, as if it did not reach around 270 degrees. So 270 degrees, so if we're looking at a clock, between 12 o'clock and 9 o'clock. This area right here is 270 degrees, okay? So this is what I was talking about with C. A percentage of land area covered with wetted solder. So land area, where this round area, it's a requirement. I mean, you can have solder there, obviously, but if you don't, that does not make it a defect because the minimum is 0, okay? Circumferential fillet and wetting of lead and barrel on solder source side. So where you're putting your solder in, that's different. You need to have solder on that land. And the lead and barrel. So that for class 3 is 330 degrees. So this is a good illustration of what 270 degrees is. It's 270 degrees is 3/4 of the way. 330 degrees would be, let me see, you know what, I'm going to 330 degrees would be that yellow circle. That would be 330 degrees. Okay. So from 12 o'clock to 11 o'clock, that's 330 degrees. Percentage of land area covered by with wetted solder on solder source side. Again, this is where you're putting your solder in. That's on the bottom. It needs to be at least 75%. Right here, what this is showing, that's a huge chunk that's not wetted very well on the left-hand side. So 6.2.3, meniscus. This right here, this is your meniscus. This is like this coating. For class 1 and 2, as an exception to table 6, on the solder destination side, the meniscus may be covered by solder, but on the solder source side, there shall be 360 degrees visible solder wetting and no visible coating meniscus in the solder. Now, it's only for class 1 and 2, so that would be D1, D2 if that requirement is not met. For class 3, the meniscus shall not be embedded in the solder at all. So that little bit of coating there is embedded in the solder. That would be a defect for class 3. Okay. Section 6.2 review. A 12-pin dip connected to a thermal plane with 68% vertical fill. So this is going to be relevant to table 6.6. Okay, so here's your information that you need. It's 12 pins. It is connected to a thermal plane, and it is 68% vertical fill, and for a class 2. So if you look at table 6.6, you want to look at 6.6. Okay, so it's 12 pins, so it's less than 14 leads, and it is connected to a thermal plane. It needs to be at least 50%. It's 68% vertical fill, so that is going to be acceptable. The goal of the process to accomplish 100% fill of the plated through hole with solder and good wetting to the, and I know I read this out loud to you. It's not the laminate. We don't want solder on the laminate, so we know it's not this one. Bend radius has nothing to do with where you solder, really, so it's not that one. Now, did I say pad or barrel? That's a tricky one, but I'll let you know it was barrel. Okay, so section 6.3, unsupported hole. So this is what an unsupported hole looks like. So with your supported hole, it looked like this, with the metal, like the foil that goes through both sides. Unsupported hole, it only has the land where you're soldering on this side, on the solder source side. Okay. Lead protrusion for unsupported holes shall meet the requirements of table 6.5, and solder shall meet the requirements of table 6.7. So circumferential wetting and fillet lead to land for class 3 should be 330 degrees. Note 2. Note 2 states for class 3 lead is wetted into the clinched area. Okay, that was a long one. Lead protrusion for unsupported holes shall meet the requirements of, and that is right there in section 6.3.1, and I'm going to give you a hint. It is a table. It is table 6.5. Circumferential wetting and fillet of the lead to land for class 2 unsupported hole is, for unsupported hole, circumferential wetting for class 2, that is going to be 207, minimum of 270 degrees. Okay, so for section 5.6, this is also in your PDF. It's just because since it came before section 6, it's a couple pages up. It's like halfway through the PDF. So 5.6, jumper wires. Jumper wires shall be permitted only by engineering documentation or other contractual action. That is N1, D2, D3. Oops. N1, D2, D3. When the criteria for jumper wires is not specified by engineering documentation, the requirements of 5.6.1 through 5.6.6.4 shall apply. And that would be a defect for all three classes if not. D3. Insulation, if present, shall be in accordance with 5.4.1.1 insulation clearance. Wire and wire overhang shall not violate minimum electrical clearance. Both of these would be D1, D2, D3 if this was not met. Wires shall not be routed over or under components. Wires shall not overhang the board edge. Wires shall not be loose enough to extend above the height of adjacent components. Insulated wires routed over or other under wires are acceptable unless restricted by engineering documentation. These, for all three of these, is A1, D2, D3. Okay. Wire staking. Staking applied to wires shall not be allowed to touch any moving parts. Staking should be applied such that it is sufficient to secure the wire with no spillover onto component leads, adjacent lands, component bodies, or end seals that may be sensitive, glass or ceramic. Wire should be staked within the radius of each bend for change of directions. For like when it goes around like this, it shall be staked at a bend radius. It can't be too sharp. Staking material shall not overhang the board. So this is D1, D2, D3 for the moving parts. Also for this one as well, D1, D2, D3. Shall not overhang the board edge. That is A1, D2, D3. If the staking adhesive shall be cured, D1, D2, D3. I keep doing that wrong. Wires shall be staked as specified. That is N1, D2, D3. So that's no requirement for class 1 for that one. Okay. For land widths greater than or equal to 6 millimeters. For land width that is greater than or equal to 6 millimeters, the wire to land interface and fillet shall be at least 2 conductor diameters. For land width that is less than 6 millimeters, which is 0.25 inches, a quarter inch. It's kind of a small amount, but not necessarily when you're soldering. The wire to land interface and fillet shall be a minimum of 50% of the land width or 2 conductor diameters, whichever is greater, and that is a defect for all 3 classes if that is not met. Why? I don't know why that's happening to me. 2, 3. D1, 2, 3. Holes with component leads. Wires shall not be soldered into plated through holes with component leads. That is A1, A2, D3. So that is only a defect for class 3. Wires shall be wrapped a minimum of 90 degrees around the leads, around flat leads, and a minimum of 180 degrees around round leads. And that would be a defect for all 3 classes. If not, wire overhang shall not violate minimum electrical clearance. Again, anytime anything violates minimum electrical clearance, it is a defect for all 3 classes. Okay. Module 4, Section 5.6. For Class 1, if jumper wire staking extends or overhangs beyond the board edge or footprint. Remember, Class 1 with this was a little different, so it's actually acceptable. Okay, that's in 5.6.3. A jumper wire soldered onto a Class 3 supported hole with a component lead into a Class 3 supported hole with a component lead is going to be a defect. Okay, that is the end of the module. Thank you very much for watching the video. Remember that you may reference this video during your test if you so desire, or you can also reference your PDF, your PowerPoint presentation that is located in your Canvas module, or you can always ask questions as well. I will see you the next test or the next class period, which will be your test. I wish you luck. Thank you very much.